right, ladies and gentlemen, so today we're taking a look at stem plots, specifically stem and leaf plots. So it says, let's use our shoe data from the random introductions to create 3 stem plots. Now, if you are attending this class because you are virtuals and you did not do the random introductions, or maybe it looked a little different, you might not necessarily have this shoe data. So I've created some shoe data for us to use that's on the board here. I have it organized based on gender, males and females, that we're then going to utilize within this chapter. And starting by creating some stem plots. You've likely have heard of a stem plot before. This is not super new to you, but we're going to go over how it's used in stats and some things that you need to keep in mind when creating stem plots in a stats class. Don't mind this trial circle thing here. It's not on your notes. It's just the tech that I'm using is under a trial versus the actual license, so that has nothing to do with notes, just as a heads up. All right. So the first thing we're going to do is create a stem plot for girls. And when creating a stem plot, we should have a title, which we already have our title here. It says stem plot for girls, boys, and then we'll do a back-to-back with stem. So the first thing we want to do is start by creating our stem. And our stem is going to have all the starting numbers here. So you can see for our females, for our girls, our smallest number is a single digit of 4, and our largest goes all the way to 45. So what that means is when we are creating our stem here, we want to have our first digit of the number on this side and our last digit of the number on the other side. So we have to go all the way to 4. So we're going to do 0, 1, 2, 3, and 4. And then from there, what I like to do is to kind of go along and check off the numbers as I use them or cross them off. I might be a little bit off screen here, so I apologize, but we have 1, 2, 3 4s, and we want this to go in order. So I'm going to have 4, 4, and a 4. And then we have a 5. And after that, we don't have any more single-digit numbers for the girls. Now I'm going to look at my stem of a 1 and find all of my numbers that are in the tens. So the smallest I have is 12. So I'm going to write in 2 because the 1 on the left side represents the first digit and the 2 on the second side represents the second to give us a value of 12. And we actually have a second 12 here, so I'm going to write another 2. And notice that as I write these, I keep my numbers on the right side of this stem piece here in line with one another. So I'm almost going to be creating a column of numbers here. The next tens number I have is I have 2 16s, so I'm going to write in 2 6s. And now we're going to go into the 20s. I have 1 25. I don't have any more 20s. I don't have any 30s, but I do have a 45. So you don't want to create something super messy. You want to keep it as nice and neat as possible. And if that was a little hard for you to see, here it is a little bit more zoomed in. I want you to do the same thing now for... Oh wait, never mind. This is a split stem, sorry. So make sure you have that copied down because next we're going to do the next type of stem plot. This one's very standard. The next one we're going to do is a split stem. And before I forget, with every stem plot that you create, you always need to have a key somewhere within your stem. And what the key is going to tell us is what the stem or how the stem plot can be interpreted. Because we can create stem plots with decimals, with hundreds and thousands of numbers and things like that. So we need to make sure we key our stem plot so we know how we're interpreting this. And so one way we could write our key is we can say 0 with the bar and 5 represents a female with 5 pairs of shoes. So I'm giving a little bit of context, and I'm making sure that the person reading this STEM plot knows what we can interpret these numbers as, whole numbers, decimals, or whatever it may be. All right, so next thing we're going to go into is called a split STEM plot. So we're going to do a split STEM plot for the boys. It's going to look very similar, but it's split. So what we're going to do is when we begin writing these stems of these numbers on the left side, we're actually going to write them all twice. So our smallest for boys is 2, and our largest is in the 20s of 27. So I need to go from 0 for these single digits to 2 for the 27. But I'm going to write 0 in here twice. I'm going to write 1 twice, and then I'm going to write 2 twice. Because this is a split stem. So this first line of zeros is for any number from 0 to 4. This second one is for any number from 5 to 9. And then this is from any number from 0 to 4, and this one's for any number from 5 to 9. So filling this in, my smallest value here is, I have 2 2s, so I'll fill that in on the first line. And then I have 2 3s. I don't have any 4s, and now I'm going to go down to the next line and see if I have anything 5 to 9. I have a 7. Oops, I wrote that on the wrong line, sorry. The 3s should be here. And then I have a 7. I have another 7. And then I have an 8. And again, I'm keeping these numbers in line together on this side. From there, oops, I have a 9 as well. Looking at our 10s, I have a 10, exactly. Then I have a 12. I don't have anything that's 15 or above, so I'm not going to have any numbers here. 20 to 24, I don't have anything, but I do have a 27, which will go here. And again, we would want to create a key. And your key can be using any part of this, it doesn't matter. So the purpose of the split stem between just a normal standard stem plot is it allows us to break down the distribution a little bit further and maybe get a better idea of any potential outliers and maybe the shape of the distribution. Because if we had everything stacked up in line here, this would have looked really top heavy up on the zeros and then very narrow here. And it still looks like that, but we can see a little bit more of the true shape of the distribution. Because we don't have quite as much stacked up just in the line of zeros. We have it broken up like this. And then the very last thing is a back-to-back stem plot. And this one says a back-to-back with split. All that means is that one, we're going to have it be split. So all of these numbers on this side will be doubled. And then it's back-to-back because we're going to include males on one side and females on the other side. So I'd recommend pausing the video, seeing how you do with the back-to-back with split, and then press play when you're ready. All right, so I'm going to fill in this back-to-back with split. Zoom out just a little bit. With the back-to-backs, what's going to happen, and maybe you just tackled one side of this versus the other side as well, because we've done this already for the boys, so we really just have to do this for the girls as well. But it's going to look kind of odd because all of our stem pieces, all of our first digit pieces are going to be here in the middle, and then all the second digit pieces are going to be on the left and right. I am going to label this so I know which side is which. I'm going to have this side be the girls and the left side be the boys. I'm going to move that writing up a little. So I know it might feel a little awkward writing these numbers on the left side, but just take your time so you don't accidentally make a mistake. Right now I'm just copying the boys down. And now looking at the girls, we have 3 4s, 1 5, but again that's going to go on the second line. And I wanted to write the girls on this side so you could get a good comparison of what it looks like a split stem versus a non-split stem. And notice that we can get a little bit more insight on the distribution here when it's split up a little bit versus when everything is super clustered, which can be helpful. When writing a key for this one, it would look the exact same. It doesn't matter which side of the stem you use to write the key. So you could even use the same key we used here. 2 bar 7 represents 27 pairs of shoes, or 0 bar 5. This key doesn't need to look special just because it's split. Okay. And that's kind of a brief overview of stem plots. Let me know if you have any questions, but that's the end of stem plots.